I'm 可以开始。
Okay, the last one, okay?
So I'm going to present my our discuss, and we go to the.
Yeah, go to the
This
hypothesis testing. Yeah.
this is my output.
Okay, okay, good.
And step 5 and 6. The first is medicine, and I expect the negative positive relationship. In this one, we do not reject the hypothesis because there is no enough evidence to infer the the um, because the
Do we start the recording? Yeah, okay.
and the next is an infer. We expect the negative relationship, and in this one, I do not reject the known hypothesis because there is not enough evidence to reject. And smoke two, we expect the negative relationship, and in this one, we reject the null hypothesis because there is enough evidence to infer null hypothesis. And the next is obesity. We expect the negative relationship. And in this one, I reject the null hypothesis. The null hypothesis. The next is gun law, and I expect the positive relationship. And I reject the null hypothesis. And the last is the metro, and is the two-sided test. In this one, I expect the positive and positive or negative the relationship. And I reject the null hypothesis.
Anything wrong with this one? Metro. You have to do the three approach, right? You just do one critical value approach and p-value approach. How do you do the confidence interval approach? This is two-sided test, right?
Yes.
So you need to do confidence interval approach. How do you do it?
I didn't do it.
You don't know how to do it? We already have 7 presenters say something about that, and you don't know how to do it?
We present before. I didn't do it, and
Now,
now I know how to do it.
okay, how to do it? Say something about it. If you want to do this one with confidence interval, how do you do it?
We use the formula.
Okay, what formula? Which one?
The beta,
Beta hat.
the beta hat
Plus and minus?
plus
Plus and minus what?
T
Critical value.
yes.
Then times the standard error of the beta coefficient. So can you do that right now?
Right?
Yeah. Based on your output. You can see from your output, right? So this is the metro. We want to do this one, confidence interval. So using this one, then
Plus and minus
critical value. What is it?
minus 2.36.
What? You said this one?
Yes.
No. This is not critical value. This is test statistic.
The T.
This is test. This is test statistic. This is not critical value. Don't be confused, okay? Okay, never mind. You can go back and review it, okay?
Okay.
All right? Then do step 7. Yeah, you have it. Okay, let me show you. Let me show you again. You are not quite clear. Here. Go upward. Did you see this one? Did you see this one?
Yes.
These two are confidence interval approach by using the formulas. Okay, go back and practice this one. Okay? All right? Then do the overall test. Step 7, overall test. Step 7, overall test.
The formula,
Mm-hmm.
and this we have this in the Excel.
Yeah, okay.
Yeah. So we have the F value
Mm-hmm.
is the 37.808, and the F statistic is 2.25.
Yeah, you had better call this one is F critical value. F critical value.
F.
All of them are F statistics, but this is by the data, and this is the critical value according to the alpha level. Okay? Don't confuse with those terms, okay?
And the p-value is the 0.0227.
Yeah, okay.
And we reject the null hypothesis.
Okay?
Yeah.
How about the conclusions about the step 8?
Protecting children through the establishment of gun law would increase life expectancy by 0.484511. A 3 percentage point reduction in the percentage of adult smoking population would increase the life expectancy by 0.665997. Although the absolute value of the gun law coefficient is much larger than the absolute value of the smoke coefficient. But it does not mean that the protecting children through gun law would have the greater impact on life.
Why? You didn't mention any reason. Why?
Because they are.
You mean you compare these two numbers? You didn't say anything. You didn't say the reason. Why? You say, although the absolute value of the gun law coefficient means this coefficient is much larger than this coefficient. No, this is smoking. What? Which one is? Coefficient is much larger than the absolute value of smoke coefficient, but it doesn't mean. Why? Why? Why it doesn't mean?
Because they are the different values.
Different values. What do you mean by different values? Is this two different values?
Yes.
No. Okay, that's it. Okay, thank you very much. Okay, I need to have some time to explain one of the questions which nobody done correctly. Okay? I'm just using this one as an example, okay? Actually, I'm showing the output. What is our expectation for this? Positive, right? And this is negative. The rest of them follow our expectation. This is two-sided, right? Although this is negative, but since we're working with two-sided, so either direction is okay. So only this 2 doesn't follow our expectation. Let's think about this one from the first one. Okay? We are talking about the positive relationship with this median income. Let me write it here. Okay? So let me show the diagram here. This one, this is T with 43. Okay? And the 5% level for the critical value for positive. Okay, since I would expect the positive. So the critical value is 1.684. Okay? And this is 0. And the test statistic, this one, is negative 0.4, let's say just 48 or 49. Okay, so it's somewhere here, maybe somewhere here. Okay, negative 0.49. Then if we're using critical value approach, I think it's pretty clear that this is rejection region. And this is a non-rejection region. So therefore, falls on the non-rejection region. Then how about p-value? What is the p-value? What's the definition about the p-value? The tail area of the test statistic, right? Now we're working with the positive sign. So what is the tail area of the test statistic? You know, this is for one-sided, right? Look at this one. You know, computer doesn't know whether we are working with two-sided or one-sided. So this p-value always follow the sign of the coefficient. Make sense? Does that make sense? The probability always follow the sign of the beta values. Okay? So we have the negative one. Means what? Means they are talking about the area of this sided, since that is negative, right? So looking at this sided, then since they do not know whether you are working with one-sided test or two-sided test, so therefore always state it as a two-sided test, because the computer doesn't know whether you want to do the one-sided test or two-sided. So if the sign follow our expectation, the p-value just divided by 2. So in other words, this is saying that from this area, the probability is 0.3141 something. But actually, our expectation is positive, right? So the tail area would be using 1 minus this one. That is the exactly true p-value for the hypothesis testing. You see what I'm saying here? I think this is really, really tricky parts. Okay? We always look at the probabilities from the output. Okay? But if the expectation sign is different from our expectation, this probability, this p-value, may not follow what we wanted. Okay? So again, we hypothesize this one is positive or negative. Unsure is bigger than life expectation is smaller. We expect this is negative, but actually this is positive. So would you tell me what's the p-value? Is divided by 2, then use 1, subtract this one, divided by 2. That's the true p-value. Okay? If you realize this one, you may say that you really understand what is hypothesis testing about the p-value approach. I think this is one of the reasons the author really recommend using critical value approach. If you're using critical value approach, we don't have this problem at all. But if we're using p-value approach, that will make difference. And since nowadays we just look at the computer output, so we are always using p-value approach instead of critical value approach. Okay? So none of you, make this correct, but I don't blame you. Most of you can do the pretty good job of the hypothesis testing. Okay, as long as I see all these 8 presenters, I think you're working with a good job. And with this foundation, then you can follow the rest of the chapters. Otherwise, I don't want all of you to learn in the foggy way. You don't know what you do. This is not the good process of learning, right? We need to definitely know what you have learned. Okay? All right, this is the one I wanted to make a comments for this assignments. Any questions? Yes?
You said you have to use 1 to minus
1 to minus this one divided by 2.
Yes, also for uninsured one?
Yeah, this is divided, uninsured, we are, expect the negative, right? We expect negative, right? So let's see. If we expect a negative,
So if we expect positive, we don't need to use 1 to minus that.
we still have to do that. Let me show the diagram. Always draw the diagram, okay? This is the T43, and we are expecting this is negative, right? So what is our critical value? Somewhere here, negative 1.6484, isn't it? Right? And the t value here is 1.25. So where is it? Somewhere here, 1.25. So this is the rejection region since we expect the negative. So this is rejection region, and this is all non-rejection region. And this number falls on the non-rejection region, right? And what's the p-value? What's the p-value? This one here, the p-value shows what? Shows this number divided by 2, right? So this here is 0.2194 divided by 2, 0.1597. So what is the p-value? Since we're working with the negative signs, so the tail should be in the, should be all the area here, right? So using 1 minus, and turn out to be, this is the p-value. So again, it's using 1 minus this one divided by 2. Yes?
What comes after this? Like,
Huh?
how do we define reject or non-reject?
Yeah, this is the p-value. And this is the critical value. So according to critical value approach, this is a critical value, right? According to the critical value approach, 1 to 25 falls on the non-rejection region. Based on the p-value, this one is greater than 5%. Also, non-reject. Yes?
Professor, if our expected sample is the same with the sign of the coefficient, do we still subtract?
Yeah, sure. If our expectation is exactly the same as the computer output, then just look at this divided by 2 is the p-value for one-sided. Does that make sense? Very logic, right? So always draw the diagram. Okay? I think, it's easy to neglect. And I think this is important, okay? And we still have sometimes, I like to say something about chapter 6. That started with chapter 6, okay? After 2 weeks, we still have assignments due. There's number 5. Yes?
Since you already discussed about it, actually, we also wanted to ask regarding how to write this, the p-value, because it didn't in line with the one that we learned, just as you explained.
Yeah, you write down the same thing like this one.
Yeah.
P-value is the tail, right?
Yeah, so this sign will follow the orthogonal hypothesis, or how do we need to write this one?
The probability that 1.25 less than,
Oh, sorry, this for an inch.
oh,
So it should be less than 1.25.
probability T2
Yeah.
greater than,
So it should be greater than
no, smaller than 1.25, smaller. The probability that the probability that T2
It's smaller than.
smaller than, still, this is our test statistic. We want you to know this parts, so which is smaller.
So it will always follow the sign of the alternative hypothesis.
Yes, because that is our direction, our expectation. Okay? All right? Is that interesting? It really burn your mind, burn your brain. Okay, let's see. Okay. Oh, I'm sorry. I need to download my PowerPoint. Wait, okay, let's just look at the chapter 6. Okay, would you please turn to the chapter 6, page 175. Okay, for chapter 6 and chapter 7, okay, are talking about the simplification. I need all of you to understand these words. In econometrics, when we say simplification, we mean the model simplification. Okay? When we say model simplification, in fact, contains three parts. One is choosing the correct independent variables, which is on chapter 6. And the other part is choosing the correct functional form, which is on chapter 7. And the third part is correct form of stochastic error terms. Usually we do have this correct stochastic error terms. Okay, so for model simplification, the important two parts is choosing the independent variables and also choosing the correct functional form. So we are going to talk about these two topics in chapter 6 and chapter 7. Then that's for the semester. Okay, now today is December the 1st. So for the whole month, we are going to cover chapter 6 and chapter 7. Okay, so we do have another 2 assignments due. Okay, so I guess one will be 2 weeks after, then the other one will another 2 weeks after. Okay, this is my plan. Then according to what we have done in the class. Okay, and let's see. Since we wanted to have we want to talk about choosing the correct independent variables. Tell me, how do we decide the independent variables in the model? How do we do it? How can we have the correct independent variable in the model? By literature review. Okay? So literature review is the first step when we learn to do the regression analysis. Okay? Always refers to the literature review, always refer to the theory. Okay? If you have already decided what you are going to study, then which is our y variables. As long as you have the y variables, you have the purpose, right? Then according to the literature review, you can decide x variables, the correct x variables. Okay? Then, in these chapters, I'm going to tell you, or let me show one example to see if I don't have correct model. Okay? What I'm going to do is using one of the example which is pretty you already know it. let's come to the class. Okay, let's get the data, and you can do this one too by yourself. I think you already have all this computer laptop with you. So whenever I'm working with the data set, you can just follow what I did. Okay, let's see. UDI 3, I think you already know this example so well. Okay, and I want to keep on using the same example in every chapters, means that the same data set can be expressed in different topic, which you have to learn when you do the regression analysis. Okay, so that's why I'm always using the same example, then you can compare the result. Okay, so according to what we have here, this is about restaurants. Y is the customer's bills number, okay? Then NPI, N is competitors, P is the population, and I is the income, okay? Then before was saying that the correct model NPI, right? Open. It's an equation. Okay, this is the model. This is the model. This is what we say. If we say, what is this? How come we have this sign? Let me get out of here. Let me have this one. Okay, this is the output we have, right? Okay, so if we know that this is the correct model, and why do we know that this is correct model? Because doing the literature review, I know I have the important 3 factors, which is the competitors and the population and also the income. Okay, so if I, for showing the examples, I have to really say that if I neglect or omit one of the variable, which is P, how do you think? What's the result? Will you have the same output as this one? No, right? Since I don't have the variable P, I just have N and I, if suppose. Okay, so for teaching purpose, I can do the example to show you how, if I made a mistake for omitting some important variables, then what happened? What the bias will occur? Okay, this is the purpose for using the examples. Nowadays, if I already know NPI is 3 important variables, I will use these 3 variables. I won't omit any one of the variables. But in the real case, if you're working your thesis, okay, if you read the literature review, but just by chance that you omit one important variables, and what will happen to your result? This is the purpose for my example, okay? So, in case, if I say, let me, okay, using this one. Where is my data? Where is my data?
Here?
Where do I have my data? Huh? Anybody tell me where's my data? Where's my original data? Where is it? Huh? Estimate? Well, maybe I need to save this output. No, this is not one. Estimates. But if I, but I want to keep the first one. I have it. How do I do it? Huh? Here? Let me see. Where do I get it? Minimize this one. This one? Ah, you go back. Ah, okay. Ah, thank you very much. Okay, let me do it this one. And okay, let me go back to my original output. Then I will save my output. Then I will go back to my. Then where is my output? Now I cannot find my output. Where is it? Corner? Oh, this one. Where? This one. Okay. Then open it. Well, very good. Okay. Thank you very much. So I put this output as equation 1. Then I can use it again and again. Okay. I won't do it several times. Okay. Now after this one. Okay. Now I just have N and I don't have P. Okay, now I run the one with Y with N and P only. So Y with N and I only. Okay, then I name it equation 2. Okay, great. Now I wanted to show equation 1 and equation 2 at the same time. I put this one here. Oh, where is it? Oh, I put this one here. Then, where's my equation? Do this one. Then choose the equation. Open it. Then this one. Make it larger. This is the first one, equation 1. Then I want it to equation 2. Where is it? Up. This one? Then?
Minimize this one.
Minimize this one.
Yeah. And
Then show the
show the equation.
equation 2. Open it. This one? This one? But I wanted to show at the same time. No. Huh? Okay. Minimize this one. This one? You know how to do it? This one? I'm always to show the equation 1. Where's my equation 2? I want to do it at the same time. This one? This one? This one? I put it here. Then open this one here. This one? Also in the middle? This one? Then open it. Huh? Then minimize it. How come I didn't know how to do it? I should know it. Okay, now. Okay, let me. What did I do? Okay, let's see. I wanted to make this. Okay, this is the output we usually have, right? So if we don't have P, then it turns out to be like this way. Okay, look at the coefficient. Okay, for the coefficient of n is changed from negative 9074 to negative 1487. It's a big difference, right? Really big difference. And I is from 1.28 to 2.32 something. Okay? In other words, if you omit one important variable, how do I know P is an important variable? How do I know?
based on the R
Based on the R square.
square.
What's the R square tell us?
The R squared has increased.
Oh, you mean that since here, adjusted the R square, this just reduced to 26%. And here we do have 58. But I like to know that what is the individual independent variable? Why do I know the individual independent variable is important? Although, from theory, then from the output, can you see that? According to the hypothesis testing, these three variables, N, P, I, all of the hypothesis testing. Okay, first of all, it followed the expectation, the sign, right? And what's the hypothesis testing tell us? For individual, for example, N. For N variables, the coefficient is beta 1, right? Is it significant? When we say significant, means reject the null hypothesis and support alternative, right? And P is also important. The P value is so small. Okay? Then I is also important. The P value, according to the one-sided test, 0.0123. Yes.
For instance, you're going to do the P-stat test, and then you're going to do the P-value test, and then you get like one test says that you don't have to reject, that you can't reject the null hypothesis, and the other test says you can actually.
No, actually, if we are doing critical value approach and p-value approach, the conclusion is always the same. It won't be conflict. This is just using the hypothesis in different ways.
With partial F-test.
Partial F-test. What do you mean by partial F-test for?
It's like there's the, I'm sorry, I don't have my literature right. We worked on that with the webcam thing. Yeah, with the wall test and all. With the partial wall test. We have F-test for overall significance. We have the same. But that's not exactly the same type of test, right?
Well, partial, for F-test, we do have the whole model. We call it overall test. And if you want to test some part of the independent variable from the model, some part, so not just only one, maybe 2 or 3, okay? So in other case, since the hypothesis testing, the alternative and non-hypothesis is different, so they may have different conclusions.
So
Okay.
As the p-value and the critical value test are supposed to give quite the same results. They don't give the exact same indication about the actual variables, but yes, we need to do both each time, every time.
Oh, no, you don't have, just do one. So for one-sided, you can choose either critical value approach or p-value approach. For two-sided, including the confidence interval approach. There are three approach. You can choose either one of them. That'll be fine. They would get to the same conclusion exactly. Okay? All right? Let me continue this next week, okay? Okay. All right. Thank you very much. That's for today.